All right, we should all be on this page. This is like the last page, it should be anyway, of your guys' packet. And so we've got one last thing to talk about, because what do we have coming up next week on Tuesday? Tests, okay? Also, what is something that you need to be working on memorizing before your test? That proof that we talked about why do the angles add up to 180 in a triangle. So if you kind of forgot about that, here's another reminder that you should be looking that over, okay? Even if you just spend like 5 minutes a day for the next couple of days, you'll probably will be able to retrieve a lot more on your test from that proof than if you just look at it the day before, okay? So the last thing we need to talk about is something called a mid-segment. And so I'm going to go over with you guys today, like, what do they look like in a triangle and what can we use them for? So what is happening with their measurements in relation to the triangle? Yesterday, when we talked about the triangle inequality, I kind of gave you some examples on that website where I was kind of messing around with the side lengths. So I have a website created for this as well that I'm going to demonstrate up here too. So make sure you guys can see the screen here. So again, feel free to turn in your desk if you need to. Sit sideways. If you guys look at this picture, it's just a triangle. Okay, and I've got a couple of sides on it, 14, 14.4, and 21. And then over here in the boxes, I'm going to start clicking on those to show you what mid-segments look like. But what a mid-segments definition is when you're connecting the midpoints of two of the sides of a triangle with a segment. So if I was looking at the side that said 14 and the side that says 21, they both would have a midpoint. Midpoint, remember, means middle. So like maybe about here would be like the middle of that side 21. If I were to connect that middle to the middle of the 14 side, or even maybe to the middle of the 14.4 side, that's going to start creating these things called mid-segments. So I'm going to put one of them in here. I'm just going to start with this mid-segment number 1. So you can kind of see that one dropped in. They're saying that it's 10.5. I'm also noticing on those lines, you see like those little arrows almost on it? Like here has a little arrow, and like here. What's that trying to tell you guys? Not the middle. Not congruent. They're parallel. Okay? So they're trying to tell you here that these little arrows are saying, hey, these two pieces on the triangle would be parallel to each other. They're never going to cross paths. Now they are also giving us some information about their measurements. They're saying that this one is 10.5. And this one is 21. Is there a connection between 10.5 and 21? Jackson? 10.5 is half of 21 is what he said. Do you guys all agree with that? Okay, so keep that in mind. And now let's look at another mid-segment. So I'm going to get rid of this one. And I'm going to put in the second one. So that new line that I just put in there, that 7.2, is that parallel to a side on the triangle as well? What side is it parallel to? The 14.4. Those are the ones with all like the 3 dashes on it. Okay, now let's go back to what Jackson just said. We had saw that middle one on the last one was 10.5, half of 21. Is 7.2 half of 14.4? Yeah, so that pattern seems to be continuing there too. All right, so let's check the third mid-segment. So there's the third one. Again, is it parallel to one of the sides? Yeah, so we've seen 3 different ones. They've all been in a different location, but they've all been parallel to something on the picture. And I'm noticing again, is 7 half of 14? It is. So that pattern of the mid-segment being half the length of the side seems to be consistent. Now, if I put all 3 mid-segments in at the same time, we can kind of see there's like a smaller triangle that's created by those mid-segments. And there'll be times in pictures where they do put all of them in, and there'll be times when they don't. Like they just maybe give you 1, or they maybe only give you 2. But sometimes they'll have all 3 in there like that. And you should be able to hopefully recognize where the mid-segments are and what do they relate to on the picture. So anytime I see a mid-segment drawn here, I should be able to identify the side that it would be parallel to. And then also remember that they have a connection of that this side should be half of whatever this side is. And the same thing goes if I was looking at this mid-segment that said 7 instead. That should be parallel to a side, and it should be half of that side as well. I also could change the numbers. Like I could take this triangle and I could stretch these sides out however I want. Okay, and I should still be able to recognize that same relationship. So now this time, if I look at that mid-segment 6.6, this is the one with like the two arrows in it. This is going to be parallel to this side over here, which is that 13.2. Well, if I take 13.2, cut it in half, I should be at 6.6. So even though I changed the way my triangle looks, it's not changing anything about what we just talked about. There's still going to be those parallel sides, and they're still going to be half. Do you guys understand what I'm talking about here? So if you guys go to your notes now, I want us to write that down, kind of summarize our thoughts there so that we can use this to help us solve problems. So coming here, let's write that down in this first box. So it says here, if a segment joins the midpoints of two sides of a triangle, then the segment is, and I want us to add that it would be parallel to one side and half of its measure. So down below we have some triangles, and you can kind of just see by looking at them, some only have one mid-segment drawn in, some have all three, but we want to continue to just think about what we just discovered. If you can recognize that there's a mid-segment, there should be a side on the triangle that it's parallel to, and then their measure should have that connection that we just discussed. So let's take a look here at letter A. I want to solve for both X and Y. Does anyone feel like they know what one of the two should be? Colby, what do you think?
Y should be 9 because it's parallel to the 18 centimeter, which means it's not.
Good. So Y is the mid-segment, and he noticed that it would be parallel to that side that says 18. And so it should be half. So yeah, that should be 9. So I'll just write underneath it 18, like divided by 2 is where we got that 9 from. Good. How about the X? Anyone see any information from the picture we could use to help us find X? Reese?
Above the midpoint, it's 8 centimeters.
Uh-huh.
Splitting it in half.
And how do we know, like the mid-segment splitting it in half?
Yeah.
Yeah. So she kind of remembered what we talked about, like this point here would be a midpoint of that side. If we know that the top portion is 8, then she's saying we should be able to know that the bottom portion is 8 too. The other thing I could maybe look at, do you guys see how this side is marked with 2 dashes? Is down here also marked with 2 dashes? What does that tell you? They're the same. So that's why it's also for sure going to be 8. Okay, what about letter B? Anyone think they know what X or Y would be? Colby?
X would be 76 degrees because it's parallel to the Y line and the 7 centimeter line are parallel with each other, which means 76 and X are corresponding.
Okay. He is saying that these two angles, the X and the 76, are corresponding because he talked about parallel lines. When we were going at that or looking at that website, we talked about the fact that those mid-segments and like the sides of the triangle would be parallel to each other. So he remembered that. He's recognizing here that 7 is a mid-segment and 7 in that side that say Y would be those parallel lines. And then this line here, like this side of the triangle, that would be your transversal. And so he saw that the X and the 76 would be corresponding, which is why he said that. That's perfect. I'm just going to write underneath that corresponding, just as a reminder. Some of those angle pairs that we talked about are still going to show up inside of these triangles because anytime we have parallel lines, those angle pairs can start to show up. Good. All right, how about the y now? How much is y? What, Mariah? It is 14. What'd you do there? Yeah, 7 times 2. They kind of switched the order on you a little bit there, like the y and the 18 on the last one. They were missing the mid-segment, and you were given the side of the triangle. This one kind of flipped it on you. You're given the mid-segment, you have to find the side of the triangle. So make sure that you remember, if you had mid-segment, you would double it. If you had the side of the triangle, you would take it divided by 2. Good. All right, how about letter C? Anyone have thoughts on what X or Y would be? Yeah, Colby.
X would be 9 because it's a mid-segment and then it's parallel with the 18 centimeter line, so it'd be half of it.
Good. X and that 18, those are those connecting mid-segment parallel sides. So yeah, we just divide it by 2. How about the Y? This one always seems to trick some students. Reese?
It's parallel to the 8 centimeter line.
So the Y is parallel to, you're saying this line is parallel to this line?
Yeah.
Yep. Do you know how much that would make Y then?
8 centimeters.
8 centimeters?
Yeah.
Does everyone agree with 8 for Y? Does anyone want to say 4? It's okay if you want to say 4, because I hear that in every single class. You are correct, though, that it's 8. All right? It is 8, but why do kids think that it would be 4? They don't double it. They don't double what side?
8 centimeters.
Yeah, because what would this side really be? 16. Okay, they see that 8. Some students will recognize that there's an 8 there, and they think, oh, that's that side, so I have to like divide it by 2. I have to take half of it. And that's where we get 4 sometimes. But that would be reading the picture a little bit incorrectly. That 8 goes to both of those sides, which is why it stays the same. So I also just want to maybe highlight that for a second here. If that y value was 8, okay, if this is 8, that means that these two smaller portions would also be 8. That same kind of connection should happen all around your picture. So like if this side we said was 9, we said x was 9 here, how much should this little piece be? 9, and this should also be 9. Okay, what if you knew that this was 3? This is unmarked, but I'm telling you, let's say it's 3. How much is this? 3, and this would be 3. So when you have those mid-segments and they're cutting those pieces in half, that's going to happen on all 3 sides. So just maybe another little thing to kind of point out, and you guys could use that in the future. All right, let's go on to letter D here. How could we solve for x? Take 9 times 2? Because 9's a mid-segment, it's parallel to that x side, so that would be 18. Good? Okay, we still have y though here. If I look at my picture, using what we just talked about, this upper piece kind of on like that, I don't know, the left side of the triangle is 12. So if this side is 12, how much is this side right below it? It's also 12. So how long is this entire side? This is 24. Okay, we know x now is 18. Add them together. Well, you're kind of on the right track. You see that little thing that's got the little asterisk by it? Pythagorean theorem? You guys know what that is? Someone said it. Was it you, Marissa? What did you say? Have y'all heard about that before? It's kind of a big deal in the math world. It gets used a lot, especially in geometry. Okay, and we're going to talk more about Pythagorean's theorem in the future. For today, we're just going to kind of get our feet wet here a little bit with it. We're not going to get into a ton of like the nitty-gritty details regarding Pythagorean's theorem, but some of you have probably been exposed to this already due to like a previous math class. When we have right triangles, we can use this theorem to help us solve for missing sides. But we have to be a little bit careful about like plugging things in. You want to make sure that you're watching for what your A and your B and your C sides would be from your triangle. The A and the B sides are pretty interchangeable because they don't really impact what you put in for A or for B, but C does matter what side we put in for C. Does anyone remember what side always has to be the C on a right triangle? Yeah, Colby?
It's the longest.
It's always the longest side, and how do you know where that longest side is? The longest side is always going to be across from the 90-degree angle in your picture. So this is always going to be your C side. And then these other two could be your A and your B. And it doesn't matter what you put in for those numbers. So like if you know the two sides that make that right angle, either one of them could be A or B. So like I could rewrite this and say this is B and this is A. You could really switch those around, but C is fixed. C also has like a really fancy name. Hypotenuse. Okay, the hypotenuse is always the longest side of a right triangle, and that always has to go in for C. Okay, all right, so now that we've kind of refreshed our brains on that, let's figure out how we would set this up. So using my picture from over there, the really big triangle in the picture, you guys were able to tell me that that full left side was 24. So that would be this side here. And then we said that the bottom, that was where the X was. We found that to be 18. I want to figure out what that Y side is. How would I plug this into my formula up above? C squared, or could I say Y squared? Yeah. Does it matter that she put the 24 first and the 18 second? Could you have flipped those? Yes. All right. I'm going to need you guys' help here. I can't do this kind of math in my head. What's 24 squared? Anyone got a calculator? Or can grab one from the table right there? Jackson?
576.
576. Anyone know what 18 squared would come out to be?
324.
Okay, equals Y squared. If we add those together, we should get 900 equals Y squared. How do you guys get rid of a squared? Square root. And the square root of 900 would be 30. So that Y side should be 30 centimeters. There will be a couple of problems on your homework that do make you use Pythagorean's theorem. So just be aware of that. If you kind of are able to get maybe most of the problem done, but then you go to find another variable and you kind of get yourself stuck, like you're not really sure what to do, that's probably telling you then like, hey, you probably need to use A squared plus B squared equals C squared. Okay? We've got one more. I want to solve for X. Think about that relationship still between the midsegment, which is where the 2x minus 1 is, and the 3x plus 4. I can't just set these equal to each other. They're not equivalent. That IH is smaller. How would be a way to like represent the difference here? Like, I'm going to get it set up a little bit, but this is not the true correct form. Like I got to add something to my problem. Multiply by 2? Multiply which side by 2? The 2x minus 1 side? Why just that side? It's half of that longer side there. So we got to double it to get to the longer edge on the bottom there. Okay, so now I'm going to distribute over here. And that's why we put it in parentheses like that, so we remind ourselves to multiply both of them by 2. So that becomes 4x minus 2 and then what? What do you get for x? 6. How could I check my answer and make sure I did it right? Plug it in. So up here for IH, what's 2 times 6 minus 1? 11. So then what should the bottom be? Should be 22. If I take 3 times 6 plus 4, is it 22? Yeah. That would just be a real quick way to check your work if you wanted to. Okay. Any questions on that? Okay. Let me get this.